So the first time, 0 gets 0. Now this is a for loop. So from here to here, it's going to repeat until this for loop ends. So the first time, it comes in and says I is 0. Grabbing a J is 0. Compare. Then it's going to loop this inner for loop first. What's the next value of J going to be when it finishes running this code?
0 again. 100.
Not when the for loop ends.
Ah, the rectangle size.
And it executes again. Because it executes from 0 to rectangle size, right? So the first time it's a 0, then it says J plus plus. It says add 1 to J. So it's going to compare, still rectangle 0, but now rectangle 1. It's going to add up again. Rectangle 0 and rectangle 2. Rectangle 0 and rectangle 3. Right? We haven't gotten back to this line yet. It's still stuck in the inner for loop. It's going to count up. It's going to count up. It's going to count up. Let me get up to, I think I have 100 of these. When it finishes, when this for loop ends and says, I've counted as high as I can go, it's going to end. When this is over, it gets here and it says, hey, I'm inside of another for loop. Let's keep doing that. The 0, now 1. Comes to another for loop. Says, hey, I've never run this guy before. Let me get J as starting value 0. And it restarts the inner process. The inner process is going to count up. So we'll have comparing rectangles 1 and 0. Then 1 and 1. 1 and 2. 1 and 3. 1 and 4. 1 and 100. It's going to keep going. This counts up. 2. 0. 2 and 1. 2 and 2. 2 and 3. 2 and 4. 2 and 5. 2 and 6. 2 and 7. 2 and 8. 2 and 99. 100. Counts up. 3. And 0. 3 and 1. 3 and 2. 3 and 3. 3 and 3. 3 and 4. 100 times. Until finally this one gets up to 99. And this gets up to 99. Every time you add a loop inside of a loop, the last loop, the one that's the smallest one in there, is the one that's going to run through all the code. It's the one that's going to loop first. He's going to run this whole loop. Well, this guy does a single iteration. He runs this whole loop again. This iterates again. This guy's going to finish looping 100 times for this to finish looping once. And because this outer loop is looping 100 times, the inner loop actually happens 100,000 times. This guy's in this Excel spreadsheet. Even though there's 0, 1, 2, 3, 4, 5 boxes, there's 6 boxes in here. We should have, I guess, 36 of these. 6 across, 6 down. There's 36 comparisons.
Times 6 is 36.
Looping 6 against looping 6. 36 comparisons. Now we found a way that we could cut that in half. Since we knew we used our noggin, and that's kind of nice. But there's still 36 intersections here. And because I have 100 and 100, I should have 100,000 intersections, 100,000 comparisons. Does that answer your question?
Yes.
Now the core of your question, though, is how does it know that A and B are different?
Yeah.
Certainly it doesn't. It's going to count up these guys, but we don't have any part that says if I doesn't equal J. That's something we need to add to make sure it never tries to check a collision on itself. So I'm going to finish doing my collision code, and then we'll get to that. So if they overlap in the X and they overlap in the Y, well, this turns out collision detected. End line. Maybe we'll give out some information. I'll say object I and object. So I'll just get to know which number they are. I think that'll be nice. Every time it says collision detected, I'll know which 2 objects collided. So I run it right now. I'm guaranteed this modulus. These have to be in. So I can't do modulus of a float. If I'm doing division with decimals, I can't have remainders. It's just going to do a decimal conversion. So that was my error. So if you left these as just constants, you're fine. All right. A lot of collisions, right? It looks like I had so many that went off the screen. The interesting one I wanted to look at, though, is every time it says collision detected, object 86 and object 86. Those are the clear errors I should fix. Collision detected, 87 and 87. So I need some more conditions in here. I need to say, if I doesn't equal J, then check all this collision stuff. How can I improve this one more step? Man, that's a lot of collision. I might increase my board size to, or just decrease the number of rectangles to 16 of them. I've got a couple collisions. Nice. Guys, what's going to be wrong, though, with my collision code right now? Collision detected, object 0 and object 1. Then it says collision detected, object 1 and object 0.
Huh.
Same collisions there multiple times. Remember, all I did, right, we haven't put this in yet. There we go. All I've done is I skipped where it was itself. That's it. But 1 and 0 overlap here, and 1 and 0 overlap there. Remember we said half of these collisions we could get rid of. How can I improve my code? To not just check for itself, but to make sure they haven't overlapped before. They haven't already resolved their own collision. Any ideas? No one has a single idea. Remember when we were doing this? We said that everything to the left side of this could also get skipped, right? Because the first one coming through is going to check collision here. 0 against 1 will get checked here, right? 0 and 1 also get checked here, so I can skip it. Can I skip any one of the ones? Yeah. Which ones? Because there's a pattern for which ones can get skipped. Let's go line by line until we figure out what the pattern is. 0 checks 1, 2, 3, 4, 5. If 0 checks 5, does 5 need to check 0? No. No. Let's find where they overlap. Let's say skip. If 0 checks against 4, does 4 need to check against 0? No. This whole row, this whole column, we can skip. Because 0 will check everyone, so no one else needs to check 0. So the next line, box 1. Doesn't need to check against 0. Doesn't need to check against 1. Have boxes 1 and 2 already checked each other? They have not. Have boxes 1 and 3 checked each other before? No. They have not. 1 and 4? No. 1 and 5? No. Alright, let's go to the next line. We skip this one. Boxes 2 and 1. Have they checked each other before?
Yes.
happened right here. I can skip it. 2 and 3?
No.
2 and 4? 2 and 5? 3 and 1.
Yes.
You guys starting to see the pattern?
Yes.
This should look like one solid piece. After we got to this middle section, everything to the left of it can get skipped. Does box 5 have to actually check any collisions? He's at the end of the list. If everyone else has checked collisions except for the last guy, you can just skip this term. Everyone else has already checked them. Right? So if you don't need to check against himself, 4 already did 1 collision. 3 will check these 2 collisions. Right? So every time as we move through the list, we have fewer and fewer collisions to check. Does that make sense? So let's talk about the code. So far the code just says skip when I and J are the same character, the same person. What kind of formula can I write to make sure I skip all of these cases?
Pseudocode or the actual?
You can give me it in pseudocode. Give me something descriptive. Call it I and J for now. Let's talk about this group again. How many things does box 0 check?
3.
He checks everyone in front of him, or behind him in line, depending on how you want to talk about the array. Everyone who's going to check after him, box 0 has to check it all. As we get further and further into the line, people standing in line only have to check for collisions behind them, right? Get an idea of what our map or what our formulas would look like? Now I is keeping track of which of these groups? This row, this column, this is I. I is going to count through all of these. J is going to count over. We can't skip any I's, can we?
No.
We can skip one of them. Which one?
0.
Box 5, the last box. The last item of our list can get skipped entirely. Everyone else in the list only skips some of the other ones, right? If these are our J's, box 3 will skip J when it's 0, they'll skip J when it's 1, they'll skip J when it's 2, they'll skip J when it's 3. So when I is equal to 3, when we're on box 3, what's the first box we have to calculate?
Box 4.
So when I is 3, what's the first value of J?
Doesn't it depend on the
No, you already said it. What'd you say? What did you say to my last question?
box 4?
Box 4. J is just keeping track of which box we're on in this group. This is box 3, that means I is 3. This is box 4, that means J is 4. So the starting value for 3 should start checking when I is a 3, the first J is a 4. Let's just finish this table. Let's make a table of all these. When I is 0, what's the first J value? What's the first other box?
1.
1. So when I is 0, J is 1. Box 1. When I is 1, what's the first value of J?
2.
Yep.
And so
What's this one going to be?
3.
You guys see the pattern? So the starting value of J is what? Give it to me in the formula. Starting J equals I plus 1. So we want to make an if statement. If we want to get rid of all those other values, how can I modify this? Right now it says, if I doesn't equal J, check for collision. That's how to make sure it never checked itself. What did we just say the value of J needs to be?
I plus 1.
It starts at I plus 1. Is J ever going to be less than I?
No.
No. Look at our right here.
J is less than I.
Is that right?
No.
It's not. J should never be less than I. So if J is greater than I, we can check collision. When J is less than I, that's when we need to stop. Those were all the early cases. Okay, so starting J is I plus 1. J will always be a larger number. So this says if J is a bigger number, check collision. Now before, it just said make sure they're not equal to each other. If J is always greater than I, will they ever be equal to each other? No, so we're also skipping those duplicates. So even if you guys don't feel comfortable with the collision code of it, you guys understand why we had to make sure? Why we only had to check for half of those cases? This is a great thing to do when you're in unknown territory. Just start making some charts. Open up Excel, look at what you need to do, and just think about it step by step. I know it's tedious when I ask you for every single one of these, all 36 of them. It can take a while, right? But it's what the computer is doing in the blink of an eye. We just need to double check some of its work. So we have the outer for loop, we have the inner for loop. We just make sure that we're only checking when J is greater than I. On the last time this runs, if we look here again, in this last run, what's the value, pretending that this was my group of boxes again, what's the final value of I going to be? In this example. How many boxes do I have, you guys?
36.
No, I have 36 collisions. I have 36 intersections.
You have 12 boxes?
I have 6 boxes. And what's the last box? Box 5. So the final value of I should be what? Yes. It'll be 6 when it breaks, but before it breaks, we'll get to 5 and we'll check for 5, right? So I'll bring up my little... When I is 5, what will J be? Is there a box 6? No.
No.
So will box 5 make any comparisons?
No.
Nope. And should it?
No.
No. Because everyone else has done that work for him. The last guy in the list, everyone else checked him out already. So our formula satisfies duplicates and makes sure, and it also skips the last guy. So if I run this code now, I won't get any more duplicates in my collision detection. Remember last time, it said collision detected between 0 and 1, and then it said collision detected between 1 and 0. There are no duplicates now. 0 and 4, 0 and 12, 0 and 14. There's no 12 and 0, there's no 14 and 0, and there's no 4 and 0, right? It didn't repeat. Right? This is combination versus permutation. We don't have duplicates. Order doesn't matter. So I've got some collisions. I never had any duplicates. All thanks to this awesome code. This little formula. That's all it took. Again, if I switch it back, if I only check for those duplicates, I'm going to see everything reordered as well. It'll say, hey, I found a collision between A and B, and I found a collision between B and A. It's not going to know the difference. 0 and 10, 0 and 14. Let's scroll down so when it counts to 10. 10 and 0. 14 and 0. The later step is called collision, which is collision resolution. If objects are overlapping, you have to push them back. We're not going to worry about that today. But I want you to be thinking, if you're going to write code that resolves these collisions, if you see objects overlapping, and we have those duplicates, they would try and move each other away, and then the other guy would find a collision and try to move each other away. You could actually have the same resolution happen twice. Cool. I'm going to make a new project. Otherwise, this is the answer to the homework. A thing we could do, and I think I saw some people starting to do this already, is for X and Y, you could have made your own structure just for those, called position. You could store the float X, float Y, And you can replace these two lines with position. Struct can store other structs. Okay?
Huh. That's cool.
It's a never-ending rabbit hole. You can make as many groups as you like. And that would just mean, right, let's say we added a third dimension to our collision detector. Technically, if we're looking at X and Y and Z as arrays, right, every array position would have an X, a Y, and a Z. It's all of Z existing in correlation to all of Y, existing in correlation to all of X. Which is why it's easy for computers to conceptualize 4 dimensions, because it's just one more variable. You don't have to be able to visualize it, but the computer can still do the same calculations for every dimension. Right? I can just keep adding lines here.
I have a question.
Yes.
If we keep practicing writing code on our own too, eventually, could we put an interface to a program like this, like so we could see the rectangles colliding?
Absolutely. And what's great about that is you could even just go find a library that someone's already written for rendering. So with minimal amount of changes, we can make this a visual solution. But the hard part, or what I think the hard part, the physics behind it. You've written the collision detection. There are all kinds of other collision detections. I'm not going to go into that rant. It's really fun to come up with solutions. For example, if I were to challenge you guys to do collision detection between circles, you have to come up with a formula that works for circles rather than for rectangles. Just as for storing a circle, if it's always a perfect circle, you wouldn't need a height and a width. You would just have a radius. Anyway, I now have a struct